critical number being 16/3. So doing the second derivative, I'm not going to rewrite it because this thing has been hard to write with having so many things open. So for our second derivative, here's our calculator. The deal for the second derivative. Now notice I have the same expression I had before. The derivative of x times the square root of 8 minus x, comma x. For the second derivative, we hit a comma a second time, another comma, excuse me, then a 2 afterwards. That means second derivative. If you do 3, it'd be the third derivative. Close parentheses, hit enter, and there it is, x minus 16 over 4 times 8 minus x to the 3 halves minus 1 over 2 times the square root of 8 minus x. Again, if I was doing this by hand, I get this down to one expression, because that makes it easier when we're taking the, trying to find it equal to 0. So here's our expression. Let's walk through what I've done here. X minus 16 over 4 times 8 minus x to the 3 halves minus 1 over 2 times the square root of 8 minus x. And that becomes x minus 16 over 4 times 8 minus x to the 3 halves equals 1 over 2 times the square root of 8 minus x. So I have 4 times 8 minus x to the 3 halves, multiply both sides by that, cancels on the left side. On the right side it reduces, leaves a 2 times 8 minus x. So x minus 16 equals 2 times 8 is 16 minus 2x. Add the 2x to both sides, add 16 to both sides, 3x equals 32, so x equals 32 thirds, excuse me. But that's not in the domain because it's bigger than 8, and the domain was negative infinity to 8. So now we're going to have our interval. Look at our intervals. Negative infinity to 0 is the first interval. We'll check 0. So a test value would be like, I don't know, negative 1. Put a 0 there. And then we'll go 0 to 16 thirds. Test value, how about 1? And then we'll check the 16 thirds. And then we'll do 16 thirds to 8. Then we'll check 8. So from 16 thirds to 8, I don't know, let's check 6. I have 8. Now here's kind of a cool thing about using these calculators. I can get my table to set up so it'll have these 4 columns. So here's our calculator, right? First thing I want to do is let me go to my y equals and just clear out what I already have there. Clear, clear, clear. So notice it's all cleared out there. Those 3 things are gone. If I go back to the home menu, our T89s have some really cool features. So I want this x times the square root of 8 minus x. I don't want the whole thing, just that part. So if I hit the shift button here and push to the side, notice how it highlights that. So I'm just going to do the x times the square root of 8 minus x. Then I can hit this green button, green diamond, and then the shift that copies it. Go over to the y equals menu. If I hit the green button and escape, that pastes it. So there's the first one. Let me go back to the home menu. If I come up here, okay, that's our second derivative. Here's our first derivative. If I hit the green button and then copy, the shift button copies it, go over to the y equals, the green button, escape, pastes it there. Hit enter. Boom, there's our first derivative. Go back to the home menu. I want the second derivative now. There's our second derivative. Hit the green button. It's copy. Okay, then I'm going to go back to the y equals, green button, escape, we'll paste it. And there it is. So we have all 3. Now I want to go to the table. Tables set is the first thing we should do. Hit the green button, F4. That'll set up our table. Now you notice what I have down here. It says independent. Most of them say auto. We want ours to say ask. So hit enter for ask, then enter to save that. Then we're going to go over to F5. Now these values we can type in. So let's start with the values on our table. We have -1 as a test value. I'm just going to go down the list. -1. And then it fills in the values across. This first column is f of x. F prime of x is the next column. F double prime of x. Then I had 0 as another value. And then we have 1. And then we have 16/3. And then we have 6. And then we have 8. So I have all those different values in there. And that 8's not surprising that it's 0 for f of x. Undefined for the other two because 8 would not be in the, you couldn't have it in the denominator because it makes it 0. So now I'm going to go back to my chart. I have this in my calculator. And now I can go forward to the chart. Now when I do the chart, what I'm really interested in for value-wise is this first column. We have -3, 0, 2.65, 8.7, 1, 8.4, 9, and 0. For the next two columns, all you care about is the sign. Is it positive or negative? So we have positive in the first row for the first derivative, and then negative. This means it's increasing and concave down. So again, I'm referencing the chart, the calculator while I'm doing this. The next one is positive, negative. This, since it's concave down, this must be, well, it's not a 0, so it's not going to be a max or a min for our first derivative. It's just an intercept. The next one we have positive, then negative. This also means increasing, concave down. Then for 16/3, it is 8.71. It's 0 for here, then negative. That means it's a critical number. Negative, so it's concave down. That means it's a maximum. And then for 6, this is an interval we're talking about. It's negative, negative. That means it's decreasing, concave down. Then we have undefined and undefined. Okay. So it asks for intercepts. We found our intercepts were at 0, 0, and 8, 0. Asks for a maximum. And there was a maximum at 16/3, comma 8.71. It asks for a minimum. There is none. It asks for increasing. It's increasing from -infinity to 16/3. For decreasing, and that's from 16/3 to 8. Then it asks for concave up, and it's never. Concave down from -infinity to 8. Anything else we needed for this? Oh, inflection points. None. And asymptotes? Also none. Okay. Well, that's it for this one. Hope it makes sense, and I hope you are able to use your calculator more effectively. Okay, goodbye.